Whenever you all are ready, can you talk me through this contraption?
Okay, so our project's a sign language detection glove, and the main idea is we have made this glove that uses 5 flex sensors, which basically measures how much each finger bends
Okay.
to detect the American Sign Language alphabets. And then our main, I guess the way it works is, again, the flex sensors detect the bend, and then certain letters have different hand angles. So we have an IMU on there that helps with,
Okay.
I guess like H and U are 2 letters that differ just by bend. And then finally we have a bunch of contact sensors, and some letters like H, U, and V, for example, they differ by like how much you bend your hand, and then how much like U and V, for example, just to have the 2 fingers separated. So that's through the contact sensors.
Okay.
And then
Yeah, so I guess we can show you some letters that kind of demonstrate like the stuff that we implemented.
Okay.
As for the flex sensors, at first we kind of hard coded it and checked like individual flex sensors for each letter. But we realized that it was a little inconsistent, so we decided to go with thresholding. And the thumb has like 2 modes where it's like straight or bent, and every other finger has 3 where it's straight, half, and fully bent.
Okay.
And so for example, A is similar to E except for the difference of a thumb. And in A, the thumb is straight like this,
Yeah.
but when you bend the thumb a little bit, it becomes E over here.
And I'll just show that as you're doing that,
Yeah.
it's translating from A
And then E.
to E
Yeah.
with that thumb movement.
Yeah, and for the IMU, so H is like this, so it takes like the accelerometer angles, and U is kind of tilted up like this. And I guess the difference between U and V is just the contact. So once I separate these fingers, it
So you're
becomes
toggling
U
there
versus
between
V.
U and V.
Yeah, and then this is like H.
Really nice.
And there are also some letters that are that require like dynamic movement. So
Okay.
for example, J is the same as I, except for you add like a little twist like that, so you can see it pops up as J based on like whether or not you're moving it.
I see. So during the motion it becomes
Yeah.
a J. Yeah.
Yeah. So yes, we can have the VJ.
VJ, we can print the sentence using the button, like to freeze the serial monitor detection. So we kind of like, for example, do the hello words. So this is H
And then E.
and E. For E. L, L.
Sorry, this one's based on sensor, so sometimes it's a bit hard.
Sure.
And we got a space.
Oh no, sorry.
No.
That works
space.
too.
There we go. And then W.
W.
O again. Let's see if this works.
O and C are pretty much the same except the contact.
Oh.
Yeah, that one we struggled a bit with. R is.
So you're trying to get the contacts right there?
Yeah.
Is that what okay.
Sorry, the thresholds are a bit hard because sometimes we realized a problem with the flex sensors where when you bend, it's kind of dynamic, so sometimes it gets a little stuck. But I don't know why this is. There we go.
R.
Yeah.
Okay.
L and D.
Hunter, is that ready to go?
Yeah.
One moment. That
So-
looks awesome.
Yeah, so we have like the current letter on the serial monitor, and we thought it'd be nice for people to be able to see like history.
Yes, sure.
Yeah.
Oh, okay, cool.
The VGA aspect here is really compelling.
Yeah. And once you fill up like one line, it goes on to the next.
Yeah.
So I guess you can kind of show that there. Yeah. Yeah.
Awesome. Were you all familiar with American Sign Language before this project, or did you learn a lot of it through the project? Okay, neat.
Yeah.
Neat. That is really impressive. Really, really impressive. impressive. So in terms of sensors, if I could just sort of enumerate them, you've got 1, 2, 3, 4, 5 flex sensors, an IMU, and then a collection of contacts.
Yeah, so we have 3 that connect to GPIOs on the RPi, and 3 that are powered. So when we connect them, it turns the pin. Yeah.
It's really, really nice. Thank you guys. That's a really cool demo.